I would like to welcome you to the last session of tonight's program, which is about smart water management. And I have the pleasure to have a number of fascinating speakers with us who are all members of the Digital Water 2020 cluster. It is a cluster of projects under the Horizon 2020 framework of the European Commission, which gathers water-related projects specializing mostly in IoT applications in the water sector, and we'll be discussing a number of interesting topics. So as you know, the name of the session basically guides us to the topic of water, water access, water supply. These are very important topics nowadays in today's society, as they are directly threatening the healthy life of the future generations. And here, IoT technologies can come as solutions and measures to support the achievement of better water quality, supporting the SDG 6 on water as well, and supporting also and helping to leverage many societal problems today. So tonight we have with us Nicolas Carrado, who is a lead working as a coordinator on the European Horizon 20 project, Digital Water City, and he's also the coordinator of Digital Water 2020 cluster, and he's working for the Competence Zentrum Wasser Berlin, leading a research and development institute on urban water management. We also have with us Juan Manuel Fernandez Montenegro, who is a senior researcher at IMAN in Spain. Is focused on AI research, development, and innovation for diverse national and European projects, also environmental related projects. Next, we have Anastasios Karakostas, who is a senior researcher at ITI SURF in Greece. And he has participated in numerous European national research projects. He will be representing the Aqua 3S project, where he is the deputy coordinator. Next, we have Lydia Bambakeridou, who is the director of WaterShare and who is a senior researcher at KWR in the Netherlands, and who will be presenting the Fireware for Water perspective. And last but not least, we have Andreas Engelund, who is a business developer at IVL Swedish Environmental Research Institute, with 25 years of experience in the field of environmental technology, and who will be presenting the School Water project. So without further ado, I would like to give the floor to Nicolas to present Digital Water City.
Thanks a lot, Anna, for the introduction. I hope you can hear me well. That you're also able to see my screen. Okay, great. So yeah, good afternoon, everybody. Thanks a lot for the introduction. I'm glad to be here today to present you some results that we have in this project called Digital Water City, related to the added value of digital solutions for water management, with a focus on sewer overflows and urban runoff. I will start directly with a few words on the project. So the main objective of this project, Digital Water City, is to link the digital and the physical world by developing a series of digital solutions for water management. So these solutions, you can see them on this small diagram on the top. They are representing along the water cycles. They use the full potential of digital technologies. It includes sensors, modeling, artificial intelligence, augmented realities, drone, mobile application. And the second objectives, beside the development of these technologies, is to test them, to demonstrate their potential, and to assess their benefits along the water value chain. So for sewer management, drinking water, or the protection of water bodies. And we are doing that in 5 different European cities, which are Paris, Copenhagen, Berlin, Milan, and Sofia. So we have, as you can imagine, very different challenges between the city. In Paris, the main objective is to improve the bathing water quality in the river for the Olympic Games of 2024, and also as a legacy for the Parisians to be able to swim in the river in a few years from now. In Copenhagen, it's about reducing flooding and environmental impacts from the sewer network. In Berlin, it's about protecting the river quality and drinking water sources from emissions from the sewer network. In Sofia, it's about optimizing costs in the management of the water infrastructures. And in Milan, it's about safe water reuse for agricultural irrigation. So today we will focus only on few case studies, on few solutions that are tested in Berlin and in Paris. In Berlin, we are working on different solutions on the sewer network to identify different sources of pollution emission. So first, we have new sensor that we use to track sewer illicit connections, which are wrong connections between the sanitary sewer network and the storm sewer network that lead to illegal discharges of sewer into the environment, untreated. And the second technology, these are low-cost temperature sensors that we use to measure combined sewer overflow, which are overflow from the sewer network into the environment that happen during strong rain events. And here the idea is to use these sensors to increase the knowledge about combined sewer overflows in cities, to increase the coverage of monitoring programs. Instead of monitoring only one or two main locations, we are able to cover a big part of the catchment or the city. And we can use this information also to improve the model that we have today on our sewer network and be able to represent better what's happening in the underground. So here I want to show you a small example. What you see on the top, it's an example of sewer network in this short video. I hope it works also with the broadcast. On the right, you see the main sewer channel. And on the left, you see that during the rain events, the level of sewer is increasing and is overflowing in an overflow channel that is going directly to the environment. It's done to avoid that the water lands on the street and cause flooding. And what you see on the bottom, it's a diagram that shows the temperature difference between two temperature sensors. One is in the sewer network. The other one is on the overflow channel. So before the event, there is a temperature difference because one is measuring water and the other is measuring the air temperature. And during the overflow event, they measure the same. So that's why the temperature difference is 0 because there is water in the overflow channel. So by using these simple techniques with cheap temperature sensors that are connected between each other, we can assess quite precisely the beginning of the overflow events in the sewer network and also the duration of these events. And we can do that not only on one location, but on all the locations where we implement this kind of sensors. So this is an example of the dashboard that is being created by the Spanish company IOTSense together with the research partner ICRA. This is an example in the south of Berlin where you see different locations that are monitored at the moment. Here on this dashboard, you see on one location, when do we have this overflow? So each blue line is the occurrence and the durations of a given overflow event. And you can see for one overflow, this is another example in Sofia in Bulgaria, where we are also testing this technology. And here on the right, you see the temperature deviations between two temperature sensors. And it happens clearly that here on this period, we have an overflow, we have the same temperature. And after the event, we have this temperature difference. So this is quite promising. The potential it does is cheaper compared to the current monitoring technology to monitor the flow and the volume or the level in the combined sewer overflow. And there are tests that are ongoing in both Berlin and Sofia to assess the precision of the technique compared to standard monitoring technology. So the second technique or the second topic that I wanted to address is the topic of water bodies. So we talk about sewer emissions. Now we are looking at the impacts. And for that, we are testing two technologies, mainly in Paris. The first one is a new technology for real-time measurement of bacterial contamination. And the second one is an early warning system to predict bathing water quality and use this information to communicate with the public. So the first technology is called the ALERT system. It's developed by the French-American company called Fluidion. It's a technology that allows online real-time measurement of bacterial concentration in the river. It means that instead of taking traditional samples and then drive and bring these samples to the lab, we are able to get directly the information about water quality on site without going to the lab. We test this technology in Paris, Berlin, and Milan, and we found that we have so far a comparable precision with the laboratory, which is quite interesting because that would mean that we could in the future use this technology instead of regular or irregular measurements coming from the lab, because it's difficult to do them every day. And with the technique here, we can have the access to results within less than 12 hours. There is a small reaction which is still happening in the device because the measurements are based on fluorescence. So we will have the final results next month, actually, from this technology. But all what has been tested now leads to the conclusion that it's quite promising in terms of maintenance needs, which is quite easy, and accuracy and precision compared to lab measurements. And we are also using this data for another purpose. With this information, we measure water quality in a given location. So we are testing that in the river in Paris, in the Seine, and in the Marne. But we also want to use this information to develop models. And this model, we call it early warning system. These are machine learning based models that predict basin water quality. So we predict this concentration of E. coli or other bacterial that we are measuring into the river, and we correlate that with different factors that might influence the water quality. So one could be, for example, rain events. When we have short-term pollution events, we might have peak of bacterial concentration. So we are calibrating this machine learning model to be able to simulate the impact of short-term pollution event. And this tool that we are currently developing in Paris is developed using the FIWARE technology. I think that will be presented more in detail in further presentation by my colleagues, that allow interoperability and the possibility to reuse this tool in other municipalities. So now we test it in Paris. We are also testing it in a small municipality in Italy. And we hope in the future that we'll be able to propose these solutions to other municipalities, knowing also that this solution is and will remain open source. So it will be easy to use the code and simply adapt the tool to local data to be able to train it and simulate basin water quality locally. So this is an example of the dashboard, the visualization that we have. On the left, we are training and validating the model. We assess a number of performance indicators to know if the model is able to reproduce what we are measuring on the river. And on the right, this example for Paris, we have different ways to select all the variables that might influence basin water quality. So mainly the rainfall, the flow, the wastewater treatment plant, the river flow, and we can select the different variables to create a model and test different models to find the best one to simulate basin water quality. And in Paris, this information will be used also to communicate with the public and inform them about the risk of contamination. So in conclusion, I just wanted to give you a grasp in this presentation about few new capacities that we have using monitorings or modeling to understand better the emissions and the impact from the sewer network into the environment. And I invite you to visit our website, Digital Water City, to find out also more about the other solutions we are testing and developing in the frame of this project. Thanks a lot for your attention.
Thank you very much, Nicolas, for this very insightful presentation and presenting the technologies you develop in your project. Now I would like to give the floor to Juan to present the updates on behalf of NAIADES. Juan, you have the floor.
Okay, 1 minute to share my screen. Can you see the presentation right now?
Yes.
Okay, thank you. So, yeah, hello everybody. I'm Juan Fernández Montenegro. I'm the technical coordinator of NAIADES, and I would like to present what we are doing in NAIADES. NAIADES project, its main objective is to create a framework of smart services that are available to smart or to water managers in the cities, so they can have easy access to all of them and apply them to solve the different issues that they have related to water management. In order to create this platform, first we check what were the requirements from the different water quality. Oh, sorry, for different water sector managers, and we check two main documents that you register the industry the industry leaders has created with different requirements from water utilities, water managers, and during the design of this framework, we try to fulfill as many as possible. Also, this framework that will contain smart solutions, our main purpose was that these solutions try to focus and to provide useful results and regarding the SDGs, and also to fulfill some of the European directives related with water. So this currently we are matching the ones that you can see in the screen, and yeah, they have been evolving during the project, and we have been adding new ones. So regarding with the requirements of the water managers, at the end, the solution that we design is interoperable, modular, scalable, and secure cloud solution. It is important, very important, the interoperability part. So it is easy, and so following different ontologies, and that it make it easy for different services, and also to make it easy the connection with other platforms. In this case, since we are focusing our services for the water management on urban areas, it is very important that also that it can be this platform to be linked with, for example, smart city platforms. For this purpose, we chose to use Fireware as the framework that help us to provide this interoperability. Mainly because it wasn't very supported by the European projects, and in Digital Water 2020, the projects that are there and are using this. So this shows that the potential of this framework. And also, we decided to make it modular and scalable, since it is required for any new modules that want to be added to this platform to be easily added. So basically, currently we have a different set of smart modules. Most of them are data-driven based modules. And all of them are so the core of the platform is based on Fireware to provide this interoperability with the Fireware data models and the Fireware APIs and NGSI LD, and the set of services that we provide are failures and detections, consumption analysis, water demand forecast, water quality forecast. These modules can be easily upgraded, and the idea is that any water manager, any water utility that wants to use to have access to this to any service, just it make it possible using Nayade's platform, where they can select the set of services that they require. Of course, they need to provide the required data for the services to work. And as a result, they will obtain the results for these smart services. And yeah, that's the main idea. So yeah, this is like a presentation of the current structure of the architecture, so the different layers of the architecture. So basically, Nayade's platform holds the data management, the services, and the final layer of the presentation to the end users. And even during the project, we also provide some support for the perception layer. We have created some specific sensors to enhance some of the smart solutions. For example, we need one chloride sensor was needed, and no, it was not available commercially. So we have prepared one chloride sensor that is currently being tested. And also regarding the interoperability, there is also a module to help water utilities to transform their data into the Naiades data models. So finally, to show a little bit what we do, how we demonstrate the use of this different set of services that Naiades propose. We have 3 different pilots. One is a city, the Council of Carus, and the other 2 are water utilities. So the set of final solutions are different. For the city, we have common issues that can be applied to any other cities, like the watering of the gardens, or in this case are swimming fountains where people can swim. And so for the watering service, combining the water demand and the user awareness services from Naiades platform, the objective of this use case is to optimize the water consumptions when watering. We measure the water need by the plants, and also we measure the amount of water that is spent on during watering, and combine it with weather information and trying to optimize and schedule the watering. And also additionally, the user awareness service provides the best route of the watering track, so to reduce the gas consumption. In this case, it is an electric track, so just to reduce the consumption of the track, reducing optimizing the route for watering. When it comes to the fountains, the objective here is to measure the water quality. Currently, the staff from Carus goes to the fountains once or twice a day to measure water quality during the summer season. And we provide real-time monitoring, so we reduce the staff workload. And also we provide water quality prediction services. The water quality predictions are meant to plan in advance any required treatment or maintenance of the fountain, because when usually when they detect the quality problems, they have to close the fountains for cleaning. And so the idea is to optimize that in order to reduce the service cuts. And the other solutions are more oriented to water utilities. The most demanded by them is the water demand prediction, short-term and long-term. So they know in advance how much water they have to pump into the city on the following days. So the idea is to reduce the water that is pumped to make it optimal for the water required by the population. And secondly, the second use cases for both water utilities are related with failures and leakages detection. In Braila, there's a specific case for leakages detection, since they have more than 40% of water losses due to leakages. So they are very interested in improving the detection of the leakages. And a similar approach is done for the saline intrusion in Alicante, since it is a coastal city. In the wastewater network, they have saline intrusions that make that the wastewater treatment processes are more difficult, and they are more they cost more. So the idea is to detect those intrusions rapidly, so they can reduce those intrusions, and that reducing its effects in the wastewater treatment. And finally, the last two use cases. One is the user awareness in Alicante, where there are specific dashboards to promote water to reduce water consumption in public buildings. So this user awareness service creates a profile of the consumers and try to inform them of the water consumption in a way that they nudge them to reduce their water consumption habits. There were a specific solution for schools in Alicante. The objective was to create like some kind of competition between schools to reduce this water consumption. Due to COVID, it has been stopped, but the intention is to continue it as soon as we can. And finally, the last service, the last solution is related with the optimization of treatments in the drinking water treatment plants. This is monitoring the inlet water of the water treatment plants to suggest the best treatments to that guarantee that the water quality for the drinking water is always okay. So yeah, these are all of the solutions that we are trying to complete in Naiades. They should be ready by the end of the year. So hopefully in next year presentation, I can provide you good results regarding these services.
Thank you very much, Juan. I think right now we need to move with the next speaker, so we'll stay on time. So right now I would like to give the floor to Tassos to present Aqua 3S. Tassos, you have the floor.
Thank you, Anna. Let me just make the full screen. I think that now you can see the full screen. Hello, I'm Tassos Karakostas from CERT, and we are coordinating the project Aqua 3S, which is actually a bit different than the other projects, since it has been part of the DRS, of the security calls of the Horizon 2020. That means that the project is, from one perspective, drinking water related project, but from another perspective is a security project. So the challenge here is that potential disasters are extremely crucial when we have to do with drinking water. So drinking water has been considered as a main source of risk, both for disasters, typical disasters like floods, but also for man-made disasters, attacks, and so on. So in Aqua 3S, we try to combine novel technologies in water safety and security, and the goal is to standardize the existing infrastructure, complemented by the state-of-the-art detection mechanisms. In other words, we try to provide a framework to present how new solutions, new innovations, new innovative solutions can be integrated into existing infrastructures. So we have a series of state-of-the-art solutions like new sensors, like IoT devices, and additionally some of the solutions that you have already heard in the previous projects, like reasoning, decision support systems, and so on. So from one point of view, we try to see the new sensors that we have developed or the new solutions that we are working, like the social media analysis and so on, how we can effectively integrate into existing infrastructure and how these solutions can actually address disasters related to drinking water. Here you can see the overall concept of the project. We have the sensors over here, we have the UAVs and the analysis of the pollution in lakes or in other water resources. We have also analysis of images regarding floods or droughts, and some input, crucial input from the social media. And all of these we are providing through a specific user interfaces to the authorities and to the other stakeholders the necessary information to enhance their preparedness. The disaster that we are trying to deal here in this project actually includes a lot of actors. It's not like a typical disaster with one stakeholder, for example, you know, a fire or whatever. Here we have a lot of stakeholders, a lot of actors that they are engaged. This is the consortium of the project. So you can see that we have some special first responders like municipalities or authorities related to water, research institutes, SME companies that provide the sensors or experience in the standardization or the integration. And we have water utility operators and water authorities that are very important to support us in the pilots. The products that we have in the project is the analysis of the UAVs, the satellite images, the new sensors, the social media analysis, and the call complaints analysis, which is rather important for our end users. And we have the integration layer, which has to do with the knowledge base, and here the firmware that we are collaborating and so on. And then all the technologies that are provided after the analysis, like crisis management scenarios, social media analysis, and so on. Our stakeholders are, of course, the citizens and the water utility operators. Here you can see the pilots, our pilots. So you can see that we have pilots in Cyprus, in Greece. Of course, CERT is located in Greece, so it was very important for us to have a pilot in Greece. 2 pilots in Bulgaria, 1 pilot in north part of Italy, 1 pilot in Paris, and 1 pilot in Belgium with Vivaqua, the water company for the water in Belgium, in Brussels. Here you can see how everything is connected. So the objective of these innovative technologies like the sensor optimization or the data collection from social media or UAVs are analyzed here, performed early warnings, and then conduct with the citizens with specific plans, and then support the water safety and the water security, which is a bit tricky term. Water safety and water security are coming from different parts of completely different domains. Okay, here are the main objectives of the project, like the strategies and methods that we are using, and in order to integrate, we are developing in order to integrate new solutions in water safety. The goal is to allow the easy engagement of different stakeholders during the crisis. Then we support the citizens with citizen mapping initiatives. And then from the other side, we have all these analysis, innovative sensor technologies in order to increase the resilience level and try to model or classify a crisis event, and some additional components that our solution provide. At the moment, we have done the first pilot. We have created the visualizations of the sensors on the 3D map and the specific graphs. We have also integrated sensors, measurements in our systems. Here, almost all these new developments are ready and will be tested in February in three pilots. And if you would like, please contact me to give you more information on these. So specific visualizations and based on the social media Earth observation data, and integration of the new sensors, detection anomalies in networks and sensor measurements in general, and of course the real-time assessments and the crisis severity level. Our project is completely relevant to the policy, to the Water Framework Directive and to the Flood Directive, with all the solutions that I have explained previously, and this is one of the main goals of us because we have to do with the standardization and of course all the policy aspects. Here is just a final slide trying to explain that the crisis, the disaster is a very complex subject. Many actors are involved, and here we provide and we try with the collaboration with other projects and with the Fire Foundation and so on to have a common ground, and then with specific solutions and use the existing IT assets that the authorities have. We're trying to update, extend their capabilities with our new solutions. And all of these under specific pilots, we try to provide standardized guidelines and support other standards regarding safety and security of drinking water. Thank you.
Thank you very much, Tassos, for your very interesting presentation. We're now moving on to the next presenter, Lydia, to present Fireware for Water. Lydia, you have the floor.
We cannot hear you, Lydia. You are muted.
Okay. Can you hear me now?
Yes.
All right. So, hello, my name is Lydia Vanvakeri-Douliroudia. I have a double affiliation. I'm at KWR, the Water Research Institute in the Netherlands, and also I'm a senior researcher at the University of Exeter in the UK. And I'm going to present Fireware for Water. Fireware for Water is a project about bringing Fireware, the platform Fireware, to the water sector. And I'm trying to advance, and I don't know how it's happening now. It's sort of stuck. Sorry, I'm trying to. Oh, there it is. Sorry. So, by contrast to the other projects, we have a more generic approach to the smart water management with emphasis on Fireware. We are looking into the digital transition from the water sector, what is it? It combines the value of water with the value of data and knowledge management, and leads to smart water management, smart homes, smart cities, and of course it's a core issue for them. For smart cities, digital twins and IoT transition. And to do this, we need digitalization and integration. We need also digital business models and customer access, products and services, and that includes also social acceptance to make all this work. We come, as the other project, for a common call, which was published by the Commission in 2018, looking for digital solutions for water, and it led to 5 sister projects, 4 from the same call, and the previous one, Aqua 3S, which Tassos just presented, which came from another call, but it had very close content, and this is the reason we are all together now in the DW 2020 cluster. So, what's the idea behind this project? We want to link the water sector to Fireware, which is an open and license-free smart solution platform. And it's the main ecosystem for smart cities initiatives for cross-domain data exchange. And how can we do this? By creation of a Fireware for Water ecosystem, which is interoperable and standardized platform and adopters of this platform, modular and open APIs to address water management challenges, and seamless integration with existing legacy system, which is very, very important if we want to adapt and if we want to expand the use of IoT technologies in the water sector, which, by the way, is a very conservative sector. And if you go to a utility and tell them you're going to need to change what you have in terms of software or whatever, they simply won't ever do it. So we need to adapt and integrate with what they already have. That includes also social innovation and citizen participation, for which we have worked a lot. We are very proud of it because we are working along citizen water forums in a couple of case studies, which means that we are making the citizen an active participator in this digital transition by understanding the value of water and the value also of IT technologies in water. And what are we trying to do? What is our target? We do all this for water sector end users, which is smart cities, water authorities, water utilities, and citizens to manage water smartly. But we are also targeting digital solution providers, SMEs, startups, private utilities, developers, because we want to boost innovation. So what we are doing, we are the building blocks. We are sort of constructing building blocks to boost this type of innovation. We took along the other projects also. We are all of us, the 5 building blocks, but in Fiber for Water, it's the main thing, what we're doing, building blocks. In a nutshell, it's a 3-year project, 5 million, 14 partners, 4 demo cases, and 3 demo networks. What's this? That's a little different. I'm going to talk about it later. And we have a number of partners, 14, with expertise in ICT, standards, data analytics, water science, social sciences, innovation, and of course, water utilities. And the project approach is, let's develop what we develop as a paradigm. Let's demonstrate it in specific smart applications and smart devices across the entire water cycle in 4 large-scale demo cases throughout Europe. What we want to do is very important, the word across the entire water cycle, because we tried to select 4 case studies which were complementary and very different from each other. None replicates the other. None has it, apart from the water sector, none has similar issues with the other, and none has a similar object with the other. And on top of this, we had what we call the tier 2 approach, which is a new thing for us and for the project. It's we are trying to engage a wide audience of water stakeholders via 3 demo networks in understanding, developing, and adopting fiber-enabled water applications using consensus building, demonstrations, and competition for SME. We just today we announced, yesterday, and today we had the presentation of the winner of the SME Challenge in another conference. So our first type of tier 2 demonstrators are municipalities. We are targeting them. The second, by creating, as we said, water forums. The second are water authorities. Again, we target them with various demonstrations, events, and so on. And then we have also the technology providers, which we try to boost SME innovation and create a growing network of adapters of this new technology. And one of these was today, where the winner was one utility from Argentina, even outside Europe. So a developer from a water utility in Argentina. And the other thing we wanted to do is to address and have water utilities, some of them public, and also we have one, Suez, which is not public, is a private, and it's a very challenging thing because they are very willing to participate. They're very good partners. Also, they're also in Alka 3S, but it's a particular challenge for us because we need to adapt to the legal and other business interests that a private for-profit company has. The other utility in the UK is again private, but it's very different because it's not a for-profit organization. And the rest are public, which has a very different aspect and approach. So when I said that we need complementary case studies, we are talking from the engineering, hydraulic, one step back point of view. What are the main problems that we have in the water sector, in the water utilities? We have flow, water, yes. How? Open channel flow. All canals and all the sewers in the end are open channel. That's case study 1, raw water supply from Athens. We have networks, distribution networks for clean water. This is case study 2, water distribution networks with the types of algorithms, sensors and problems. Then we have wastewater treatment, which is our 3rd case study in Amsterdam. And the 4th one has to do with smart meters and communication with the customers, which means what are you going to say, how are you going to interact with the customers, and in the end, building applications for the customer, smart applications to follow their own consumption. So these 4 case studies, which have been selected explicitly and specifically because they are different, they cover all types of, say, hydraulic problems that any utility or any developer may encounter in terms of, I would say, variety in the water sector. And what we are doing is we are trying to formalize the use of a context broker architecture for all of them using Firework, based on IoT stack, sensing network, data processing, and application layers. We are developing data models. Data models are the key building blocks of this, and we're developing data models for all those case studies. And this is where the DW 2020 and the other project came very willingly and very effectively also to contribute, because they added their own data models from their own case studies, and sometimes they covered things which we didn't, because we didn't have this case. For instance, social media crawling, for instance, drones, for instance, other things that came from other projects. And it's very, very important that all of these were added and are building now a library of data models through the Firework organization, which is usable for the next generation of projects, but also for the water utilities in the future. So we're working with data models. We have completed for the EPNet, which is the most widely used software for distribution networks across the world, and wastewater treatment plants, open channel flow, smart water meters, and customer interaction apps. We are working very, very carefully with the interactions and interface with legacy systems. And we have all types of legacy systems and all types of issues with them. And we are trying to, as I said, to face them as the core issue for smart cities and digital twins and IoT transition. So I have here, you can see the, I would say, the architecture of the context broker and how we work with it. All the projects that you heard today are working along these lines. And thank you for your attention.
Thank you very much, Lydia, for your presentation. Last but not least, we have with us Andreas, who is also going to present the applications in school water. Andreas, you have the floor.
Yes, thank you, Anna. It's a pleasure to be here in the IoT Week and present the school water project. I'm Andreas Englund. I'm Innovation Manager in the project, which means that I'm looking at the commercialization of the technologies that we are developing. And I will go through an overview over the project. And tonight I will, since we have limited time, go in a little bit deeper in one specific technology. And the background, as we have heard from several of the other projects, is that we have climate changes and urbanization have increased cities' challenges for managing wastewater, stormwater, and flooding events. And the question is, how can cities handle these in a cost-efficient way while addressing UN development goals, EU policies and directives, engaging citizens in sustainable water management, as well as contributing to the growing market for water related to SMEs. That is the central questions within Horizon 2020 School Water Innovation Project. and ScoreWater want to ensure the resilience of European cities. And we are doing this together with partners in Sweden, with IVL, Swedish Environmental Institute, which are coordinator in Sweden, and several companies working in the sector, Talkpool, who work with IoT, Swedish Hydro with specific technology of working with cleaning stormwater at construction sites, and Gothenburg City and the utility of Gothenburg on the west coast of Sweden, and Universium, who is a science center which has tens of thousands of visitors every year, especially young people, and we use that for our communication with citizens. We also have partners in Spain with ICRA and ERCAT as their research partners, and then we also have ESCAN, who is a sensor company, and we have Becasa IRMB as a public municipality and public utility. Also, we have partners in Netherlands with Civity, who works with FireWare. So as we heard from Lydia in her project, we have a similar approach with the data market, and we have a lot of synergy effects with the other projects here, especially on this building the FireWare data market. We also work with Future City in this area, and we are working with Amersfoort municipality and companies in the Netherlands. We have 3 cases. The goal of the ScoreWater is to develop and collect data and test water, smart digital solution and best practice to strengthen cities' resilience, focusing on wastewater, flooding, stormwater monitoring and management. And in Amersfoort, we are looking at flood prevention and climate resilience. In Barcelona, we look at resilient sewer systems and sewer sociology. And in Gothenburg, we are looking at water-safe infrastructure projects. And I will go a little bit deeper into the Gothenburg project, where we are specifically, we are testing a lot of sensors, but we are also testing a new patented sensor developed by IVL, which will work to measure turbidity and water level. And it we have calculated on, then we looked at the technology to make it cost efficient, both in investment and in maintenance. This turbinate can be used for early warning of pollutions, or for predictive maintenance of city pipelines and networks for waste and stormwater. It is based on image processing and edge AE to predict turbidity and water level. And the data collected can be used for preventive maintenance of city or municipality pipeline network, or for waste and stormwater. And I will briefly show you how the technology works. It's by processing the information of both sensor and system level with AE, an estimate of the load of a deviation in the network over time creates insights needed to for predictive maintenance of the system. So how it works is that you have a light beam or laser beam here, and you have a camera, and you get this picture in the water. And when you analyze this picture with AE, you can, with the length, you can see the depth and the dispersion pattern of the light. You can estimate turbidity. Turbidity is a measure of how much particles you have in the water. So that's a good approximation of pollution in the water for early warning system before you go to do deeper analysis. So that's how it works. And what we see as the innovative elements, we have done quite extensive market research to see what's on the market. And at the moment, there are, of course, a lot of turbidity sensors on the market, but there are no low maintenance cost, as is because we mount it in a pipe close to the ground and place it above the water. And that's, I think, is the essential thing. This is the only sensor for measuring turbidity that can be used without putting any parts in the water. And that's very beneficial, since when you work with water, you almost always get growth of algae and other things on sensors you put in the water, which means that it gets much lower maintenance if you can do the measurements without putting any parts in the water. We also have low energy consumption and fully powered by battery. I think it's 2 years time at the prototype we have now, and it could be improved. And we also have a robust design for monitoring wastewater in the dark environment. Altogether, it reduces the workload related to maintenance, including cleaning the sensor as well as power supply, preparation, and mounting of the sensors significantly. And the main benefits with a connected low-cost, low-maintenance turbidity sensor is early warning of pollutants in waste and stormwater systems. Today, there are very little measurements of stormwater, and we are testing this particularly on construction sites, which has regulations on how much they can emit, and they need some cost-efficient way of monitoring this. But we can also have another application, which is increased capacity in the waste and stormwater system, which leads to less environmental impact and fewer floods. We can also have fewer manual inspections, which saves times and travel and creates fewer traffic disruptions. We also have longer service lives on the pipe network, as measures such as the flushing system are taken only when needed. And we also can work with leakage detection in the pipe network by monitoring the trends of turbidity in nearby sensors to distinguish local changes in sections of pipes. And these are all questions that we know, since we have involved both the utility of Gothenburg, but we also work with the utility of Stockholm, and we have contact with other utilities, and we see these are real problems that the utilities want to have solved, but it has to be solved in a cost-efficient way that doesn't create maintenance and so on. So that's what we're aiming for. This is one example of technologies that we have in the project. We have several other interesting projects, but I don't think I have the time to go into that tonight. So thank you very much for allowing me to present tonight. Oh, we can't hear you, Anna.
Oh, thank you very much, Andreas, for your presentation. I can ask all the panelists now to come back online with the cameras. So we have received a number of comments from the audience, and I'd like to answer them first. So the first one is addressed at Water City, asking, are you using commercial sensors to measure water quality parameters? And also what parameters you measured in the water? I guess, Nicolas, this is for you.
Yeah. Yes, we are. Yeah, the quick answer is yes, we are using different commercial sensors, mainly at the wastewater treatment plants, to measure different parameters such as conductivity, pH, temperature, turbidity. So yeah, I will not enter right now in the details, but by checking on our website, you can see on the wastewater treatment plant the type of solutions we are developing, and we explain also on which sensor are relying these solutions, to which kind of sensor we are using. This is for the water quality part. We are not developing new sensors for water quality, apart the one I presented, which is for measurement of bacterial concentrations.
Thank you. Another question we have is at Andreas, asking what TRL level is the turbinator?
We are right now testing it in real environment, so I would say TRL 5. We have, as you saw in the picture, that was an early prototype, but the other picture that was showing is where we have a more better design now. So we're doing a small series of 50 sensors, but I would say still we are on 5, because there is a lot of challenges working with neural networks, especially when it comes to communication with IoT. We are using both LoRaWAN and 5G and so on, and it's not always easy to penetrate the lids of the pipes. So there is a lot of challenges. So I would say TRL5.
Thank you for your answers. So before we close, we have reflected a lot on what you have developed in the various projects, and thank you very much for your fascinating presentations and for sharing with us the progress of your work. One common question I would like to ask each of you to explain briefly, what, according to you, are the biggest challenges in the adoption of IoT technologies for the water sector? Tassos, maybe you want to start?
Yes, of course, Anna. I think that the biggest problem is that we have very different utilities, very different water companies. They have a different type of water, different type of infrastructure, different type of resources, different type of customers. You know, it's a completely nothing is standardized. You know, so even the smallest sensor, you need to test it in different ways in each utility. So I think that this is the biggest problem, the biggest challenge that we have. And probably an answer to this is to make small steps in order to test, not from the beginning the whole picture, but to take small steps. And the solutions that we have presented all together today are, I think, towards this direction.
Lydia, would you like to say a few words?
Well, Tassos is right. I would like to say that another problem, a challenge, which is on the business side, is that the water sector is very small compared to, say, the energy sector. That means that there are not enough developers and big companies investing in developing standardized solutions or good solutions or ubiquitous solutions. And this is also on top of the diversity of the sector that Tassos presented, but presents real challenges when it comes to business models for any project, any product that might go to the market. I mean, the market analysis is not something that attracts developers in developing big-scale standardized solutions for the IoT sector.
Juan, would you have any thoughts regarding this from the Naiades perspective, maybe?
Yeah, mostly I agree with them. And from Naiades' point of view, and as an artificial intelligence researcher, the main problem that we have encountered is, as in many artificial intelligence solutions, the access to data. And we have found that to access or asking for some specific data that the water utilities are supposed to have stored, but we always find some difficulties because they didn't manage that data properly. This data is lost, and we encounter many issues like that. That makes it more difficult to apply some specific solutions that should be applied easier.
Thank you, Juan. Nicolas, would you have any also ideas regarding this question?
Yeah, no, so I fully agree with what has been said. On interoperability, it's surely a challenge, and we see that all the projects are also focusing on that. So make sure that the devices are connected, that the data are connected, and that we can develop solutions based on the available data. I will add maybe the challenge of capacity building to make sure that in the utilities, we also have skills to understand the solutions, to understand how the solutions are working. I'm thinking, for example, at artificial intelligence. It's nice to develop machine learning and artificial intelligence tools, but we have to be sure that on the long term, they can be understood, explained, and further developed also locally by the utility. And maybe a last point I want to mention is the topic of data governance, to make sure that the solutions we are developing are implemented in the structures of the utilities and are not just tests or pilots. So understand processes for data management and also the transparency of the decisions, how we go from the data productions to decision making, and what are all the processes that happen at the utilities to make it happen.
Andreas, any last thoughts?
Yeah, I agree with all the speakers that, I mean, the fragmentation of the customers is really a big issue. And then on top of that, as Lydia said, the sector per se is quite small compared with other sectors where IoT is implemented. So it's a small sector that is fragmented. And if I want to add something to that, it's also from a technical point of view, it's quite harsh environments that you are going to get IoT to work within. So you can't transfer from other sectors. You need to do robust systems. And that's very difficult when you have a small market and a fragmented market.
Thank you very much to all for your feedback and for your interesting presentations. I believe that we have reached the end of our session tonight. So thank you once again for taking the time to be here with us. Thank you for the audience for your reactions. One last comment is to just follow us on social media to follow the progress of our work. I'm just resharing the links in the chat box for those of you who are interested, and visit our websites as well to stay on top of what we're doing. So thank you again to all of you, and I hope to see you in the next sessions. Thank you so much. Goodbye.
Thank you. Goodbye.
Thank you. Have a nice day.
Bye.
Goodbye.